My name is Steve Rostedt. I'm curious, how many people here have ever heard of Ftrace? It's function tracing, tracing inside the kernel, graph tracing. I'm the maintainer, creator of it. I partially took some of the code from Ingo Molnar's latency tracer from the real-time patch, used some of my own code that I've done from helping me debug my master's thesis back in 1999, 2000, so whatever that was, the 2.1 kernel at the time, and then I kind of put everything together, and it was basically, Ftrace got into the kernel by saying, hey, we got this, a lot of people said, we got this nice little tracer inside real-time kernel, can we get that into mainline? So I'll do that, I'll throw in some of my own ideas, make it plug-inable, make it so people could add to it. And then it kind of became very successful, and everyone started adding to it, and then next thing you know, I'm not doing real-time anymore, I'm actually doing tracing, but that's not exactly what I wanted to do. I got stuck with it. But in the meantime, I started doing other things. People were complaining about the debugfs file system interface of Ftrace, so I wrote this tool called Trace Command. And Trace Command was an interface to make it easier so you don't have to go through doing echo 1 and remember all these crazy files and commands. The Trace Command had a man page and could help you do Ftrace. Everything you can do in Ftrace you can do pretty much with Trace Command, and made it a lot easier to understand. But then I was basically saying I wanted a bigger picture with this. So I sent out an email to Wireshark asking them to the development list, I plan on, I want to basically visualize tracing from Ftrace. Wireshark kind of does some things that I like. Could anyone help me make a plugin for Wireshark to read the Ftrace output? I got 0 responses. I guess no one cared. I mean, if you search Google, you'll see the email that I wrote this nice long email. 0. No one replied. And I said, okay, this is useless. Let me go look at Wireshark. And then I looked at the code of Wireshark and realized, no, this is really specific to networking. I mean, it was just too much work. And I always had this idea, this is my threshold. If I could take someone else's code and use it, or the learning curve to use it, or the learning curve to modify it to what I want to do, is less than me writing the code from scratch myself, I will learn it. But if it's equal to or above, I say, screw it, I'll write it myself. And that's where KernelShark came from. So maybe I'll keep the slides for now. So basically, there's Trace Command. Has anyone ever used Trace Command? I've given tutorials on Trace Command, everything like that. A few people? So, I'll show you how you need to use Trace Command as much. It's a great tool to use. It's all ASCII command line. I may even do a demo that shows you some nice things that you can do over the network. So Trace Command, records to a file called trace.dat, or any file. You can just say, give it any name you want. It'll record to that file, and then you can read it. The crash utility, if you have kexec, kdump, now that's what it's going to do. I was going to install it and actually do a demo of it. If you have kexec, kdump, and have a crash and use the crash utility, there is actually an extension, called trace, extend trace. Lai Yangsan, I know I bastardized pronouncing his name, but Lai wrote the extension. I've written patches on top of it that creates it. So it'll actually create a trace.dat file. It actually reads the Ftrace ring buffers within the core dump file. So if you're running a trace and it crashes and you get a kexec dump, you can actually, there's an extension in the crash utility to pull out the trace.dat file, and you can use Trace Command and KernelShark on that. So that's basically what Trace Command Record looks like. I just have a few examples up there. You have Trace Command Record, whatever. Dash E means, battery sign. Dash E means event, sked. Sked, when you do a dash E event, it can either be an event group. This is all the schedule events are underneath the system sked. So if you just type dash E sked, it's all schedule events. Or you can specifically, I don't know if I have anything here that shows any particular, you could say I only want this event. And you can also do, P is like for plugin, but that's what, I hate the name plugin for this command. Ftrace has plugins, Trace Command has plugins. They're two different things, two meanings. But this plugin here is actually the Ftrace plugin name. I'll get to that a little bit. So you say function, that means it's going to run the function tracer. You can run the function graph tracer. If you do Trace Command list, it'll show you everything you can do. Once you have the file, default it reads Trace Command trace.dat. That's the file that Trace Command Record will give you, and Trace Command Record just defaults and tries to read that. If you do -O on Trace Command Record -O file name, it'll write to that file instead. For trace command report, you do -I, file name, you get that file. And it gives you a little nice little output like what Ftrace would give you through the output. This is all raw data file. It's not reading the trace file from Ftrace. It's actually, the data has been restored in that file, and you can read the file directly. You don't need to, you can read it on any machine you want. By the way, this is an embedded process or embedded conference, and I want to let you know that if you run this on ARM and put it over on PowerPC, you can still read the file. Or to Intel. I mean, I have a 64-bit PowerPC that I do my records. I throw it to a 32-bit Intel box and I read it. It has no problem with big Indian, little Indian, 32-bit, 64-bit. All that information is within the trace.dat file, and all the utility for the trace command report knows how to parse that information and give you the correct output. But this is not about trace command. Like if I were going to talk about trace command, I would spend the whole hour on it. I was hoping some people, ooh, but it broke. So the trace command, I'll just hold on to it.
Just put it in a pocket.
Yeah, I ruined my pocket. These jeans shrunk on me.
Sure.
So, anyway, I'm not going to talk about trace command. I may do a little bit touch. Oh my God. Damn. Go away. Thank you. Hey, listen to me. But KernelShark is a nice little utility to graphically show things. What you have, when you open up KernelShark, it shows each CPU that you have here. And each different color of this is actually a different task. And this is a big, I don't know what was it. This trace, I can't remember. Let me see what it says. 36, 35, 1, 2, yeah, it's a little over a second. That's a little bit over a second on a trace. So this is all the tasks that were different colors is a different task. So it's kind of hard to see anything. Below that would be the information that you would see, over here too. Below that would be the information that you would see in the trace stat report or trace command report file. But if you want to zoom in, because really all this black, like yeah, that doesn't show you much information you want. So you left click the mouse button and just drag it, and this line appears. You bring it over to the right, and this window where you let go, that will become the new window, the size. So you can if I just do a little bit, that zooms in a lot. If you don't zoom in, there's actually a minimum size that I have where that just cancels it. If you don't push it over to the right, it'll just cancel the zoom because sometimes you click and oh, I didn't need to do that. If you kind of line it up and let go, it won't zoom anything. But so there's a minimum increase. But you keep zooming in, zooming in, zooming in. And once you let go of it zooms all the way in, and you can zoom to see what's in there. When it's a blank line, that means it's idle. That means there's no task running at that time. This might be an old picture. There was a bug where if you zoomed in too much and all the events disappeared, it'll show a blank line when it really wasn't idle. But I fixed that. And this might be, like I said, old slide. To zoom out, it's just pick and drag to the left. When you let go, what it does is it basically takes those 2 points and zooms it so those 2 points will be on the same pixel again. So that's how. So the farther you go to the left, the farther you zoom out. It will stop at the maximum from when the default, when you start up KernelShark, will be the full trace file. So it won't go any further than that. And also, you can't zoom in anymore. It always got to at least be one event. If there's no event, it'll stop zooming. When you move the mouse over one of the events, these little, see how it's flat here and these little guys that ticks up? Those are the actual events. The bar just means that there's a task. I'm neglecting you guys. The bar over here is, right there is just saying that there's a task running. These little ticks means that there's an event down here that it's tracing. So any event that's traced will pop up with these little ticks out of the bar. When you move the mouse across one of those ticks, it'll give you a little box that tells you what that event is. Graph markers are kind of nice, because sometimes you want to calculate what's the difference in time between this dot or this dot. Or sometimes you want to make a little marker just so when you zoom in, you have a reference that you know where you are, because sometimes it's hard to find where you are when you're zooming in. You can put a marker in there and you can keep zooming. You can say, okay, here's the spot that I clicked last time. So there's 2 markers, actually there's 3 but there's 2 main markers. There's marker A, marker B. left click on the mouse button, it gives you just left click, boom, it will give you marker A. And so you say on a line. If you shift the key, press the shift key and hit the left mouse button again, it gives you marker B. What's really nice about this is it tells you the time up on top about where the marker A is, and up on top where marker B is, and also the delta between marker A and B. So,
Can't see very well this.
yeah, the mark between that is 16 microseconds. Between those two, if you look at the delta, it says that's 16 microseconds. These are in seconds, so it's 0 dot, 0, 0, 0, 0, so you kind of have to count the zeros to figure out if it's microseconds, nanoseconds, or whatever. The graph cursor is a little bit different. It's a double click on the line. Like I said, there was actually 3 markers. This is actually the 3rd marker, is a graph cursor. But when you do a double click, you get a cursor. It actually pulls the list view right where you double click. So if there's an event, it tries to find the event closest to where you clicked, and the list view below it will suddenly zoom into that location. Oh, I didn't show it. Oh, I thought I had it. Let me assume. So let me see it. That's what I showed you. It would have selected like that. Let me go back. CPU plots, task plots. Okay, by default, you already saw what a CPU plot is. A CPU plot is showing you all the events on that single CPU with ticks going up on every single event. Different colors means different tasks. But then say you want just, I don't care about all the tasks. I only want to see this one task. I don't care what CPU it's on. Just show you this one task. Well, we also have task plots. And when you pick a task plot, the colors of that you see is dependent on which CPU it was on. So if you see the task changing lots of colors, it's migrating like crazy. If it's one single color, then you know, okay, that task is stayed on the same CPU. Well, it's also kind of nice. Let's see. I click there. Let's see. Well, here, oh, I see what I'm doing there. I didn't notice up in the top corner. I just had a little mouse there because I had that stupid mirror screen. So I should have killed GNOME properties. That would have disappeared. Anyway, if you click up on top, you'll see, plots. You could add CPUs, tasks. So if you select tasks, it gives you this little pop-up that shows you all the tasks that were recorded in your trace.dat file. So you can go and pick which tasks you want to see. There's not really Bugzilla, but the last time I presented something like this to a customer, they said, "Is there a click all and click or clear and click?" I'm like, "No." He said, "Could you add one?" I said, "Okay, I haven't done that yet." But there was only a way to add all and clear all if you want. But once you do that, you'll see that now there's the tasks. And each different color is, the bottom part is the color is the CPU. The color on the top is actually the same color that you would see in the CPU tab. So the event that pops up is actually the color, the task color stays the same as what you would see in the CPU. So that kind of helps you tell, ooh, where's this task on the CPU? So you can try to find it that way. So if you zoom in, and this is where the markers kind of nice. Another little thing, since I'm kind of more into real time and stuff like that, I kind of like to know how long things wake up. So I threw in a little hook in KernelShark. So when you're doing a plot on a task, you see these little green lines over here? You see that green little box, the empty box? That means if you recorded in your trace, wake up and sched switch, you'll get these lines. If you don't have the wake up and sched switch events in your trace, this won't show up. What this means is this guy was woken up at that point, but didn't run until this point. So that little green line shows you the wake up latency. So if I want to see what the wake up latency is, I could click left mouse button and click right mouse button, and there. It took 479 microseconds from the time it was actually woken up to the time it actually was scheduled in. And what was it? Oh, I think I was just, and also you could re-click all over again. So you can move that around. It's not stuck. If every time you do a shift right, you move the marker B. Every time you don't, just click with the left mouse button, it's marker A. CPU plots, if you open out, you get this. You can pick all CPUs, show CPUs, remove CPUs. Oops. That's no big deal. See, I got rid of a CPU plot. I didn't want to see it there, but I can add it back. List view is a little bit more down here. This is basically what you would see inside, what's it called, Ftrace when you want to come down here. You can do things like, you can search this list. So if you're looking back, there's a search menu up on top here. And you can click on what column you want to search on, what if it contains, if it doesn't contain, or there's like what type of match you would like. full match, doesn't have, I don't like, I don't want, anything that has this in its line or in that column, get rid of it. You could filter that, or you could jump to find the next one that doesn't have something. So I was searching for, I think, latency. This is the latency trace. It's actually documented in documentation ftrace.txt what these funny notation means. I should add that as a help menu too for KernelShark. I'll do that. By the way, I don't think I've talked about this, but there is a help up on top here. If you click on help, there's a full web page on. Basically, everything I'm talking about right now is also described in the help menu as well. It'll bring you up. It uses GTK, help or something like that that will find a web browser or something and pop up a web browser and give you the tutorial for it. That comes with KernelShark. But sometimes you don't filtering. Like I said, you can just plot something. Let's say you want to filter out something. So you want to filter out tasks. You don't care about some tasks, or there's tasks that you just want to see. So you can filter out all the tasks. You pick tasks that you want to see, or you say, I don't want to see these other tasks. For example, trace command itself, when it records, it traces itself. So if it does an event that's being recorded, trace command will be there, and you can see it. Some people say, well, why don't you not show that? Well, then the problem is the Heisenberg principle. Whenever you trace something, it's going to affect what you're tracing. Seeing when trace command started and is running is actually a good thing. That lets you know if you see a latency somewhere, then you look at, oh shoot, the tracer kicked in, and maybe I can modify the tracer not to interfere so much. But it's good sometimes to see that the tracer is interfering with what you're trying to measure. So that's why people told me, can you make it disappear automatically? I'm like, no. But you could select it and say, if you don't want to see it, you could actually filter and say, ignore this guy. So to filter process, there's several ways. One thing is if you do a right mouse button on the list view, it pops up a little menu, and you can say, I want to add this guy to the filter or remove it or hide it. So I want to add it to the filter, which is kind of strange. When I say add to a filter, it actually means I only want to see this. So maybe the terminology is not that great. It's not like it's filtering out, it's actually filtering in. So it could be a little bit confusing. Maybe I'll change it. I don't know. And then what you do is once you add it, it doesn't disappear right away. You actually have to enable the list filter. So you add it once, and then you say, okay, enable list filter, and then it will disappear. Oh, that's right. Scheduling events. These events actually can confuse you when you do filtering. The reason why it does is because scheduling events have two tasks involved. So schedule switch, well, you have a previous task and the next task. Sched wake up, you have the task that's wake up another task. Well, in the filtering algorithm, it looks at both. So if a single event, if you say, I want to see this task, if it's on the wake, if a task wakes that event, or another task wakes up the task you want to see, that event will be shown, which sometimes confuses you because when you see the event, it's actually running from someone else. You say, I filtered this guy out, why is it still here? Well, because it's waking up the task that you want to see. It doesn't work with hide. If you say, I want to hide something, if one of the tasks, it will still show up because the other one, you didn't say you want to hide. You want to say, I want to hide both sides, then it will disappear. Basically, whenever there's one of the schedule switch events has a task that you would be seeing normally, that event will appear. So I'm saying that because sometimes that confuses people. List events. So if you want to filter on events, you can click on filter. That's why it's hard to see because the top thing is filter up there. That's what that underneath my mirror thing. So it pops up all the events that are shown. So now if you say list events, it shows you all the events that are defined inside in your trace file. Sometimes the event may not exactly exist in the data, but it exists on the machine. And if like when trace command records, it tries to make it so it could understand all everything about the machine, and it puts it into the trace.dat file. That way, that's how you can move it from machine to machine, and that trace.dat file can be read and get all your information. So if an event was recorded, like you said, record this event, but it never triggered, that event will show up in this list, although it may never show up in your, it may not actually be in the data, but if you said I wanted to trace it, even though that trace event never triggered, you'll see the information, you'll see it pop up in the trace reports file on this event filters, which is kind of good because then you can see, oh, this event never triggered. So when it opens up, you can say, remember I said about the sched group, everything's broke up by groups. Here, if I click on it, open up a window, here's all the actual schedule events. This one has it all. You can disable all events, enable all events that you would want to see. And then you can filter on them. So what you do is I click on the all, it clears everything off. And then I go through and I pick just sched switch, sched wake up. These are the only things I want to see. And then the ticks disappear. You'll see a lot less ticks on the window because they're being, what's it called, done, filtered out. Anyway, another thing is the graph view and the list view actually have two different filters. Oops, that's not what I want to do. The graph view and the list view have two different filters. So what happens is you can actually have the graph hide things, but the list view still show things. By default, they're always in sync. So you can actually click on a button and say unsync them, and now it will keep them the same trace or the same filter at the time, but any changes you make to the filter will only affect one or the other. Then afterward, then you're like, oh shoot, you can say sync them back up again, and then it'll ask you, do you want the list view to sync up with the graph view, or do you want the graph view to sync up with the list view? And you can pick that one and then it'll modify that. There's advanced event filtering, so say if you want, you're only specific about a certain instance. Now you could write a little filter logic to say, I'm only interested in this event if this field is greater than that field, or vice versa. By the way, all this stuff is also available in the trace command report. And it's all documented. This information is all there. So down at the bottom, I said the sched switch. You have what's called here. See this one? Sched switch. Sched. The sched switch. If the next prio is less than 100, and the previous prio is greater than 100, but does not equal 0. It's not. So basically a real-time task. Like I said. Or idle, or no, it's not idle. Like I want, previous PID does not equal 0. So I don't care about idle, but any other sched other task, this switch, I'm like, here, I want to filter on these events. And it will show you, it will filter. This is the grammar for the filtering. So it actually shows you all the filtering logic you can do. This is actually in the man page of Trace Command Report. If you go there, this actually cut and paste this from the man page. So, if you download it from my Git tree, if you go git.kernel.org and search for my name, Rostedt, you'll see trace command.git. Download that. That has KernelShark as well. Just know, because this is an embedded environment, I want to say trace command does not, when you do make, it will just build trace command. You have to type make GUI to build KernelShark. The reason why is because I have embedded devices that will not build a GUI, and I still want to build trace command on it. So I make it so trace command will always run on an embedded device, but when KernelShark may not, or build on an embedded device when KernelShark may not. Fields, not in events. Here's an interesting little thing. This is kind of a trick thing. So what happens if you say previous PID does not equal 0, okay? But previous PID doesn't exist. Well, this is a funny thing. So you say previous PID does not equal 0, but previous PID does not exist for this event that you're tracing. So you can say I want to trace this event, this event, and this event, and only one of them actually has a previous PID as a field of that event. Well, those always default to false. So that's why if I say sched, previous PID greater or not equal to 0, does not equal sched, not previous PID equals 0. Because it makes the one thing prove false. So if I say previous PID does not equal 0, and previous PID does not exist, that turns into false. So the next one down below that, if you look, you see sched, not previous PID equals 0. Well, that previous PID equals 0 turns to false. And you say not, so now that's true. So these two are not the same, because if the field or event does not contain that field, the smallest part turns to false. And this is actually useful when you do things like sched, because that's the sched group. And I'm filtering on the sched group, and I'm filtering lots of different events. Some of them don't have certain fields, but so what you can do is you can put in false state, force it to be false, so you can, and change it to say, or like I said, not previous PID equals 0. That would be true on events that don't have it, but then you can put in and something else, and then put a not whatever. So you can actually make it so all events do what you want by playing with this trick. You can do regular expressions. It uses the regex, man regex or 7 regex in there. So if you do equal tilde or not tilde, kind of like in Perl. I'm a Perl guy, so that's why I do it. That way you could do full regular expressions that's defined by man 7 regex. So you can get kind of interesting results. When you do an advanced filter, like I said, click on advanced filter. And then you go back and look at your filter events. And the filter events, like I said, I only want to pick certain events. You'll notice that this advanced filter is grayed out, which means that it doesn't exist. if you zero out all filters, you could lose this guy. So the way you could, sometimes I'd say do your advanced filters first, then go and pick in the general events. So see, adding events. To delete an advanced filter, specifically, when you open it up, you'll see the events that you have. This is kind of interesting because if I did a, you know it's only sched switches there or whatever, but if I did sched, which is a group of events, and then go back, actually each individual event underneath sched will have its own delete. You could delete it by itself, because it's really, the filters are per event, not per group. It's just the way you enter it in, you could just do, hey, have all these guys handle it. And for the ands and ors that are not there, it will optimize them out for when you go and look at it. Here's something new to trace command, is trace command recording. Or not trace, KernelShark recording. So KernelShark recording, what it does is, I click on, let me go back, capture, which is, like, this is actually a new slide, because if you look at the other slides, that capture doesn't exist in the menu bar, if anyone noticed that. But suddenly capture appeared. It's, so if I just started, this is actually, I made this slide today. Sorry, Dirk, I made it during your speech. I was listening. Anyway, I made the slide today, I pop it up, and without any data file, so it comes up empty. So I say, okay, trace command record, and when you hit record, this window pops up. And it has all the, you pick events that you want to trace. So I go down and pick, I want to trace this event, this event, this event. This is actually to execute trace command. I could then pick, say if I remember the plugin, the function graph tracer, the function tracer, so it looks at what's on your machine. Only thing is you have to be root to do this, because this type of execution, you have to have root privileges, so you actually have to start KernelShark as root to be able to do this. I plan on adding it so a PAM module to say, you know, please enter root password to do that. Right now, no, you have to execute it. So the security beware. But you'll be doing this on your test boards anyway, so you really don't care about security. After you hit run, or you click run, and it's boom, it runs. And it runs, and if it actually, you notice back here, oops, in the run, I added like an ls, I just said ls-ltr, whatever, /bin or whatever, just to record something. That will command. If you don't put anything there and you hit run, that run button turns to stop. It just sits and waits until you hit stop, then it stops recording. And once it does that, then it pops up right away. You'll see in the background all your recording events. So since I have 10 minutes, or 20 minutes, which is perfect because I really didn't want to talk too much. I want to actually play. So first I want to show this little thing. I have my guess at the startup. I click just for, this is more trace command. Hello, is that, I thought I paused it. Is it running? Okay. It's not running here. Hello. This is control alt. Shut up. Just hit that and it runs again? Or? There we go. So, yeah. In another window, a demo. I don't have to be root. yes. So if I run trace command listen, and I do port 1, 2, 3, 4, 5. So now I actually created a daemon, and there's a way that -d would actually be a real daemon. But this is now, it opens up port 1, 2, 3, 4, 5. So this guy, I do trace command record -e, let's do all events, what the heck, and do -N. Usually if you do -o, that would be an output file, but I don't want to go to output, I want to do network. And I do Frodo at 1, 2, 3, 4, 5. And let's just go and see what happens. So it starts recording all events that's in the system, and I hit Control C. And it stops it. And now if I go back to here, you notice that, oh, you guys can't see. What was it, Control Shift plus? There. Is that good? Okay. You notice that it connected to SAM. Yes, this guy's called Frodo, and of course that guy's SAM. Order ring span. It had one CPU, tells you what the page size was, and the version that's running in. Ignore the offset stuff. That's actually where in the file where the data is being stored at the offset. And it says, hey, I'm connected. Boom. And then it's done. Then it's done. So let me Control-C out of that. And KernelShark. Oh, you'll notice that it created in that directory instead of doing trace.dat file, because it's a listing and you get multiple clients, if everything went to trace.dat, one client would overwrite someone else's client. So to make it different, I say, okay, who did come? It puts in the host name, what port that was their side was connected from. So when Sam connected to me, it connected to 38,237.dat. No, and so just to see KernelShark, and you just put in that file name and hit enter. Oh, I should crash. Boom. There, I got KernelShark. There, it pops up. Right here, I can just move over. You'll see all the things that happen. Zoom in. Zoom in. Especially if you press down and you forget how to zoom. If you just press and hold, it shows you what you do. You just let go of it right in. Double click. It takes you down here to the event that I double clicked nearby. So let's even zoom all the way in. Ooh. There, so that's a double click. Now if I do this graph follows, I like this. Click here. And yes, I have bugs I have to clean. That little line that sticks up, it doesn't see. But I can move through the events, and it follows as I go down here. So whatever I do down on the bottom, the graph is going to follow with the cursor. Take that off, and it's back to normal. And this guy, right mouse button, let's say I just want to plot this guy, plot him, shows up here. And the graph files again. And here I can see where the wake up was. If I click right there, that's probably a wake up. Yep, this guy was woken up at that time. Like I said, left mouse button will do a little tick there, shift. And that's approximately 6 microseconds. As you can see up here, it says 6 microseconds between those 2 points. And a 6 microsecond wake up. Want to plot more? Okay, plot different tasks. XOR. And see what the XOR looks like. Jeez, did it run at all? Oh, because of, didn't do much. Another little, let me see. When you do capture, record. Oh wait, let me get out of here because I did not root. Ooh. Something's happening. My screen is blinking. So I'm like, what the heck is going on? Now capture, record. By the way, if you do filters and you do all these advanced filters, and you're like, well, I'll get to that too. I have 15 minutes. So here I have all the events that I want to, record. So I could say schedule switch. These are the ones I like, schedule, because they're kind of interesting. Plug in shows you like a function graph tracer or whatnot into this file right here. I could change the file. I can hit browse and look for something else. This is just telling you max how much output here, because I found out that if you add this is all saved in memory, and if you put too much, you can overflow. If you're just letting something run forever, this screen can't overflow. So this was max display output, kind of like a terminal. Like how many, how much do you want? How many characters do you want in your terminal? Actually, terminal's more by lines. I did by characters. And if I just hit run, notice I didn't hit any. It shows you the trace command, what it did, actually how it did trace command, how it executed it. So actually I'm doing execute right now, and if you want to know, you can type here, then I can actually cut and paste what I did here. If it's there, yeah, I don't have text, there it is. Just cut and paste it. I think you can do probably copy, probably not. Yep, copy. You cut and paste that text. It basically gives you the command it ran, and if you can do the same thing on the kernel command line. There, full thing. And that's if you want to know how to run something on trace command. There, KernelShark will do it for you. And if you notice in the background after I did all this, this is what happened on the CPU. So whenever this has room, and this is a little bit buggy algorithm, but whenever it has room, it tries to put in, show you the event online a little bit, so you don't have to zoom always all the way in or put in here. Notice the blanks are idle until I come over here and it'll tell you this is QEMU, the KVM that I'm running session right here, process, and then when I put over here, it gives you a little bit more information. Double click, again, takes you down to where you want to see something. If I want to enable filters, let's see here, let me zoom back out. Oops. Let's see, you have to add a task. Well, let me enable a filter in this. Add QEMU to filters, sure. And let's just filter, enable filter. Now, there, that's all QEMU that's running right now. Any event, right? Was that add tab? And remember I said, this is interesting, remember I told you, like, well, why is it all different colors? Because it's just one event. So if I actually zoom in, down here, you'll see here, it's all trace command ran, but it did a sched wake up. Right? Oh, there's a trace list. Oh, did I filter here? Enable list filter. I only enabled the filter up there, not let me enable the list filter. There we go. This is it's QEMU, if it's on either side, here's a perfect example. QEMU is being scheduled in, although you'll see Firefox is the main task, but QEMU was scheduled in, so that event shows up. And probably on wake-ups, you'll probably see the same thing. If anything ever woke up the QEMU, KVM machine, like here, you'll see both sides of the events. Also, when you go into the capture and record, it keeps back your information. Record remembers that. But you can also save settings. So if I wanted to save this, I can click and save the settings. And right now, this will record all the settings that I did for here. So I could save it. The reason why I'm doing that is because, I'm not going to save it now, I did my migration test. On LWN, I wrote a little thing about using KernelShark for analyzing the scheduler. This is actually the utility that I use for it. So I just set it up. Now this is showing, again, all the stuff this migrate was a setting I saved. If you do save settings, it automatically stores it in your home directory setting. And so you don't have to, once you save something, it'll give it a name, it will appear in this list from then on. You can import settings from a file or export settings from a file. Well, if I record this guy, let me run this one now. Now when I run this, my machine should hang for a while. Because when I run it, this is the migration test I'm running as root. It's doing real-time task. It basically overloads the CPUs with real-time tasks. Okay, so it ran everything, shows you the output of the thing. You close this. Now the thing is, what happened? There's nothing. Anyone can tell me why there's nothing on my list? Okay, anyone paying attention? I have the filters on. Clear task filter. Boom. Then you get a nice little pretty diagram. You zoom in, and these are all, and what I usually like to do is, I don't like to see, I also like to do filters. Filter on let me sync. Unsync, oh, filter on tasks, because I don't care about anything but my migration tests. So I go down and I'm like, the first migration is the parent that kicked off everyone else, so I can ignore him, but I just want to see these guys. And you can't really see much, but yeah, this is what it looks like. And also let me plot the tasks too, because that actually makes it more interesting as well. So, let me pull this up so you can see it. So you can see how, here's a nice little thing. See this red line? When you do I showed you the green line where it was when a process was woken up and when it ran. The red line means it was scheduled out in a running state. So the red line means it's been preempted, and you can now see, how long has this guy been preempted for? So something came in and kicked it off. So this guy, CPU 0, so up here, that's this guy up here. So right here, it got preempted, and then and then as you see by the different colors, it was also migrated to a different CPU at the time. So a lot of migration happens. What I showed here is this is the highest priority process is the bottom guy, and he keeps changing colors, which isn't a good thing. This actually has the old scheduler this is the point of the article, was I'm trying to prove that the old method of the scheduler caused the highest priority task to bounce around the CPU a lot. And yeah, remember I told you if you don't go zoom in too much. So you can see how it bounces around. And I can zoom in and see like why is this happening. You'll see a lot of ticks other than scheduling. The reason why you'll see these other ticks is because should disable filters. Yeah. See if I can find. Do I have a pop filter on there? Oh, that's all Vance. I figured I would find something here. Otherwise, here we go. That's what I'm looking for. Print. The reason why you have extra spaces here because it actually has 2 lines in the print. Another thing that's been fixed is I've got to work on fix. The migration test, another little thing for if you ever want to write into the Ftrace buffer, there's a file that you could actually write into, which, let me see if I can. So if I do cd to debug tracing right there, most places would be sys kernel debug. I don't like to type sys kernel, so I just mount it at debug. But you'll see this thing called trace marker. And let me do this. Trace command start -e something, I don't know what's the. Oh, that's a good. Scad kthread stop. That's a good thing to try. Trace command, record, or no, start. Start is just saying, just start it, don't record anything. I mean, it actually just starts Ftrace recording, but it doesn't actually record to a file. And so if I cat trace, that's what's in the kernel buffer right now. And if what I like is this thing called marker. It actually, you could, from user space right into the kernel buffer, right there. What the trace command, what this migrate test did, and you could see the code on LWN, latest weekly news. It actually, what it does, it opens up trace marker as a file descriptor, and then periodically writes status into the buffer. So now, when I'm analyzing the test, I can actually see what the user space is actually doing. So that's one way you can communicate. Well, anyway, about 4 or 5 minutes left. Is there any questions, or you want more demos, or? Okay, right here.
Do you have some kind of version of the tool to LTG?
Was that LTT and G?
Yeah.
Matthew and I are good friends. So actually, a lot of times, I tried to use Trace GUI sort of a long time ago to get it when I was doing Ftrace to be my viewer, but I couldn't get it working. So I said, you know what? LTTNG to me is something that's more it's very focused on users. And I was kind of more focused on kernel developers. And so a lot of times, and also more small embedded stuff. Although LTTNG is good maybe for both, but sometimes I figure it's a big hammer. I'm trying to become simple. I'm trying to keep all this as simple as possible. Which also brings up another thing. I plan on adding a bunch of plugins. I fell in love with the operation DL open. So I'm going to be adding plugins. Like I want to basically make KernelShark do almost anything you really want it to do. And it's kind of like you put in a plugin. I plan on doing histograms. It will soon be reading perf. I'm going to make it do. I want to make it do the histograms that Frank was showing earlier today. Okay, I wanted to do it automatically, so you don't have to hack your own stuff. Just add it in, and it will show you things like that. And just write a plugin to do it, or whatever. I'm trying to make it featureable like that. And basically, it's my playground. Now, if I were to use LTTNG or something like that, I'm kind of stuck. It's a lot harder. And Matthew and I are good friends, but we disagree on almost everything. so that's why it really hasn't been much collaboration. Although we share ideas all the time. So, there's another question. Oh, you have no?
Is there an option to, when you have a trace, you can double click or see the source code with the reference or call stack?
For the call stack of a single line, like for a function in the trace command, you can do that. Now I have to be very careful. I'm going to do this, I might lock up my laptop. Now the reason why I say this is there's in function graph tracer, there's a, let me do just echo, sorry, trace command, record or start, whatever, function, and let's say, let me filter on something, schedule. I'll do schedule. Filter, which is limit schedule. Oops. So there's the schedule tracer. Now I do that purposely because what I want to do is now cat options. There's ls options. There's a file called func stack trace. So if I do, let me go someplace else. cd to trace command, record. Let me go right back up because I don't want to do a typo. The reason why I'm very careful about this typo with this schedule, -o, which is an option, func stack trace. There we go. Well, let me do a record on it, just for the hell of it. Okay, it should. Let's see if it worked. It gives you all the people that called the stack trace of all that called function. Now you have to be very careful when you use this with the function tracer because by default the function tracer traces all functions in the kernel. If you do a function stack trace, if you enable that option when you don't have the filter enabled, it will do a stack trace on all functions being called. Well, this could have a problem because it slows down the kernel more than magnitudes. And yes, filter. And then you set. Once you know what it is, I've been saying I should do this since for a long time ago, which is I should make it so you can't do that. If you don't have a filter, it will not enable that option. I just haven't gotten around to doing it. It's one of my to-do lists. But if you do that, you'll walk. And then why is my machine not working? What happens is the interrupt handler, the timer interrupt handler, is taking a lot longer than a single time. Like, all interrupts take a lot longer than the next interrupt coming in. So it's basically interrupt storm kind of thing. It's like no time, but time expired. But is there any more questions of it? Or I know it's lunchtime, so yes.
We're going to get the latest.
Latest KernelShark. Go to git.kernel.org, search for my name, Rostedt, and look for trace command. Trace -cmd. You'll see I have a git tree, tracecmd.git. Download that. That's my development tree. Okay. Any other questions? Yes.
So right now, there's no way to display user-defined links?
Not yet. If we get uprobes into the kernel, there might be. Well, so that's a lot of functionality. I will say I'll plug ELC2011. Supposedly his stuff has the ability to do things like that. So I mean, like I said, I'm friends with Matthew. We disagree, but
the command line tool does it have dependencies on any libraries?
Does it have any significant libraries? I don't think so. I have trace command working on my little MIPS board from remote. Okay, so I mean, and that's almost BusyBox, you know. So yeah, and well, it has some libraries. It's a glibc. I mean, yeah, glibc. What? I haven't tried it on ulib, but I mean, I really do focus it for a lot of the stuff. Is like from people who do embedded, and they ask for enhancements, and I'm fully supporting embedded devices. So if you have trouble, that's why I said trace command is a separate make. You actually have to take make GUI, but otherwise, you don't want to put like poor KernelShark to some of these devices. Anything else? Thank you very much.